Alright guys, I'm going to require you to use something other than the online C compiler. I don't want to let you guys come out from this class and doesn't know how to use Vim. So I want to push it a little bit harder because super necessary, even though it's not being written into the curriculum or syllabus in this class. I'm not giving you a quiz. It's your decision if you want to follow my instruction or not. So I'm going to show you how to do it this class, and I hope everyone, since you guys are computer science plus computer engineering majors or electrical engineers, either way, you should know how to do it. So I will require you to do it. However, I'm not giving you a quiz. I'm not examining this as well. There won't be any exam on the commands, but for the homework assignments, some of them will require you to have a snapshot with outcome from the output from the command line and using Vim. So you can definitely use. It's been so many different versions. I think the most recent Microsoft Visual Studio, just whatever. You can change it to the Vim command version, but I don't know how to do it. However, you can definitely just follow what I have been doing in this following class to run your simulation for the first few weeks. Because after the first few weeks, it's going to be totally on the embedded C. So you are not going to have a chance to program in another different editor at all. So everything will be written in the MP Lab X or something for programming the PIC microcontroller. Does that make sense? Okay. But for when you're practicing with the C coding, I think let's do it in Vim. Okay, it looks better. If you use the online C compiler, it's gonna ruin my reputation. I don't want you guys come out from this class and just to know how to use online compilers, C compilers. Okay, all right. Yeah, I'm doing my teachcation anyway. But still don't want to ruin my reputation anyway. So even though I'm super relaxing and teaching super easy stuff, C compilers and C programming, the easiest money you can make. You want to make easy money is become a professor. Take a PhD degree, become a professor, and pretend you know everything, actually you know nothing, and just teach. Some quick notes for the homework. What is this number in 2's complement in binary? Negative 1, right? Why? Because this is minus 2 and plus 1, which is negative 1, right? So what about this? You're not changing the value by adding 1s in front of it. So what is this number in 2's complement? It's positive 1, right? If you're adding 0 in front of it, it's not changing the value as well. So the conclusion is, if you replicate the MSB of the 2's complement binary numbers, you're not changing the value. So you're wondering, hey, this is definitely not negative 1 in reality, in the real world, right? It's definitely, you have how many? 7 1s. So if 7 1s is 255?
Or 127 probably.
Oh, 127?
1s would be 255.
Because here will be, oh yeah, 127 probably. Anyway, so physically, right? 1 is 1. 1 is 1. However, we force the computer to treat this guy as minus 1. You know what I'm saying? If it's signed, it's going to be minus 1. If it's unsigned, it will be, if it's unsigned,
127.
it will be positive 127. Okay? Thing to talk about overflow. We didn't finish it. 2's complement overflow. So like I said, P plus P got an N, which is overflow. N plus N, you got a P, which is overflow as well. However, P N, you are getting an N, or P N, you are getting a P. They are not overflow. They're not defined as overflow. Why does that matters? It probably doesn't matter in the high-level programming languages like C, C++. It matters when you are dealing with hardware design in FPGAs. One of you guys asked that question. Do we have to, whenever there's overflow, do we have to duplicate the MSB and put in front of it as a real MSB? I'm going to show you one example so you know what I'm talking, since I'm not expecting you can remember what I said last week. The answer is no, because the C compiler will directly sort everything out. You don't need to manually manipulate the binary bits. However, in FPGAs, when you are designing a flatter, you have learned flatter in logic, probably, right? Flatter, subtractor, you put them in the one structure, you do need an overflow indicator to change the MSB. We don't worry about that, so you don't have to understand that for now. But let me show you some examples what's happening here. So how we define overflow for two's complement or it's not overflow. So if we have 101 plus 101, what's happening? In two's complement, okay? So this is 0, this is 1, and we're always looking at here to determine it's positive or negative for these cases, right? So 1 plus 1 is what? It has a carry out,
0.
And this is getting 0. So you're getting N, and P, right? Just looking at the third MSB here, not adding the carry out first. So just looking at this is N and P. So satisfies this situation. So this is definitely an overflow here. It's overflow. The reason we define this as overflow is in hardware, we have to take a certain action if it's overflow or not overflow. So overflow here is not carry out. These cases, like P plus N got a P, P plus N got an N, they also have a carry out. You cannot use that carry out as the MSB. I'm going to show you some examples, you'll see. Because two's complement are not the real numbers. They were made up. So if they're made up, definitely you do all the additions, you're getting errors. Right? I'll show you examples. Now it's okay if you don't understand what's going on. But let's see the example. So for this one is overflow. For overflow, what you want to do in hardware, not the C level, but Verilog level, what you want to do is adopt. Overflow, then adopt the carry out. Usually this is called C2, carry 2. As MSB, as MSB. So it's going to be 1, right? So adopt it, use it, MSB. So what's the result? Just looking at this one as a two's complement, because you are telling the computer to use the same rule. Two's complement will be two's complement. The MSB will be negated. And this number will be -8, and this is 2, right? And you're getting -6. And this is -3, so you should get -6 as well. So matches, they match. So it's correct. If you adopt it, it's correct. If you drop it or toss it, do they still match?
No.
No. So see here, at the very bottom transistor register level, you have to tell the hardware that if there's overflow, I want to adopt this guy. Adopt C2. Let's take a look at another example here. Let's take a look at another example. 111 plus 001. 0, 0, 0, right? Okay. Which are getting N, P, what? P. It's a 0, so it's a P. Does this satisfy any of the the cases here for overflow? No. So is there overflow? No. Is there a carry out? Yes. Could you tell the difference? So overflow we are talking about for two's complement could be different from the other cases. Okay. Sometimes we just not abuse, but kind of abuse that term overflow. We use it whenever there's a carry out. However, it's not the case. For two's complement, overflow is overflow. It's labeled as OV, and you have to design a certain logic gates to get the flag, turn it on, so you can do the following actions. The following actions is you are adopting the carry out as MSB. You concatenation. You have heard about that, right? So combine them together to make a 4-bit binary result as the correct two's complement result. However, here is there overflow? No. So do we want to adopt C2? Let's try it. Adopt it, what's going to happen? So what is this number? 1 and 1. I just talked about that here.
-1.
What is this number?
Positive 1.
What's the result? Should be
0.
0. If you add a 1 here, is it 0?
No.
What's the number here? Yeah. So see, overflow will be a flag. You want to determine if you want to adopt it. So now, do you want to adopt it?
No.
No. So in hardware, what you can do? So what we do is actually, because the adders comes down, you got all the S0. Don't want to confuse you, but this is S0, S1, S2. Okay? So what we usually do in hardware, we just duplicate S2 as MSB. It's always getting you the correct answer. So if there's no overflow, just duplicate it. Doesn't matter if there's a carry out or not. Just let you guys know. You are not using this for embedded. Just let you guys know. Okay? So this was happening. So I think if we know this, even though we don't have a chance to design the full adder by ourselves, I don't know if you are doing that for the VLSI class, but if you can reach here, I think everything about tooth complement is crystal clear. There won't be any confusion anymore in the future. It's everything about tooth complement. Okay? Just adopt it. It's gonna be always right. Let's see. If there's no carry, so this case has a carry out, right? But there must be cases that don't have a carry out. Let's see, 0, 0, 1 plus 0, 0, 1. 1 plus 1 is 2. Definitely won't have any carry out. You have 3 bits. Come on. So what's happening here? You got a 1, 0, 0, right? Okay. So it's P, and what? P. Overflow or not? No. Okay. What you'll do for the hardware? Like what I said, the rules. Overflow, adopt C2, which is a carry out, the real carry out. No overflow, do what? Duplicate S2. Like I said, duplicate it. If you duplicate it, what's going to happen? So it's going to be 0, 0, 1, 0. Is it changing the value?
No.
No, still 2. Still getting the correct answer. Okay? So when you are using tooth complement, it must be making errors. And you have to use these kind of rules to tell the computer what to do to get the correct answer.
So are you saying that when it follows the NMP or VPN, there is overflow?
Yes.
You take, what is C2?
C2 is a carry out, so that's something like we can talk about really quick if you're interested.
It was more of a clarification question.
Yeah, let me show you really quick. I can get it done in a minute. 2 minutes.
If there's no carry, or if it's not one of those overflow cases, you simply duplicate the bit?
Yes, duplicate S2. That's how I do it in the hardware, in Verilog level. At Verilog level, not C level. C level can directly the compiler deal with it. The compiler already, when it compiles, change it to the machine code. It does everything for you.
S2 being the frontmost bit or whatever, right?
Yeah. Just in case, okay? Usually called the serial carry 0, carry 1, carry 2, okay? And this is a flatter, the carry in, we just call it C minus 1. And you are getting a result, summation, S0, S1, S2. So this is C2. If it's unsigned, this is always the MSB, because it's a 4-bit binary number, will be the final result, because you design the logic for the flatter. You probably have done that in logic. So you design the circuit here, you have A0, B0, A1, B1, A2, B2. So you are basically adding B2, B1, B0 as a 3-bit binary number to A2, A1, A0. Just adding them together, right? So B0 plus A0, you are getting a little carry. If it carries out, just so on and so forth. And eventually, you get a final carry. We call it C2 as a MSB. If it's unsigned, it's okay. We do everything right. It's not getting you any errors because these are designed following the truth table. So not making any mistakes. However, if it's a truth complement, you have to adding some logic to it to indicate if they're overflow or not. Because overflow or not, it's giving you different results. Doesn't matter if you have a carry out. Is that clear? Okay, making you sleepy? What's that?
Sorry, I missed it. What does that say by the C on the very right?
Here?
Yes.
It's a carry in. Because you see here, the full adder has how many inputs and how many outputs? Full adder. Full adder. What's the full adder inputs?
3 inputs.
Three inputs, right? A, B, carry in, right? How many outputs? Summation, carry out. Okay? So we got carry in, A, B. Carry out, summation. Is that clear? These are the inputs and outputs for the logic. Like this. Carry in, result, carry out, could be 0, could be 1, 2 inputs. Don't want to spend too much time on this. Anyway, but is that clear? You have a lot of two's complement problems in the homework assignment, so I want you guys to understand what's going on. Okay, another thing I want you guys to look at. Okay, the computer system use two's complement. You just have to admit that because it's happening. So if you go to programmer, okay, if it shows a 0, it's not really showing anything. You probably couldn't see it clearly, right? But it's recorded, so just come back to the video if you want to look at it. So look at the numbers. Look at the numbers. So for decimal, another quiz question. So how many bits do I have for the computer usually, for the modern computers? 64 bits, right? So we're expecting 64 bits, 64 binary bits as a result. And the calculator shows you that result. So if you want to show a -1, for example, I'm using 0 minus 1, okay? 0 minus 1 is going to give you -1. So in the binary result, in the binary column here, or row here, what you are expecting? 0 minus 1, what you are expecting as a result? 64 ones. But physically, is 64 ones really -1?
No.
Let's do a quiz. What's the number is? I'm kidding. So that will be 2 to the 65th minus 1, right?
Yeah.
Cool. Let's try it. So 0 minus 1 equals. See?
Huh.
Did you see the binary row here? What the results looks like? So the computer fakes it that way. Fakes it. It's just a two's complement. Make sense?
Yeah.
Okay.
That's fine.
Yeah? Good to know, right? Okay, let's do our programming a little bit. So like I said, I expect you guys to follow the good practice. All right? So I think starting from homework 2, you'll see there are requirements of snapshots in Vim and command line to complete these two C programming problems. So you have to follow the certain steps to set up GVim and command line in your computer. If you're using Linux, it could be directly just programming in the command line. I think you don't even need to set up anything. You'll probably just download a GCC compiler. So if you click it, you'll see the steps. So the first part of the tutorial, it's a pretty short tutorial, was from many years ago. I did it for the C++ compiler. However, it's the same steps. I think you can see the same interfaces, and you should take the same actions to make it work. So the only difference is the Segwin interface looks slightly different, but I think if you follow it, it should get it done. Okay, should be able to get it done. And then you have to download GVim as well. I have to learn. You won't be used to it if you haven't used it before. But practice for a few days. It will be.
Is it like the same setup for Macs?
For Macs, what is Mac?
Like
Apple computers.
Oh, Macs.
Pretty sure you just use Vim, 'cause it's a
Yeah, I think.
program.
Yeah, because Macs is based on Linux system, I
It's
think.
based on Unix.
Based on Unix. Similar commands, I think. You can turn on the terminal and start doing all the programming. But definitely search and see what are the solutions to it. Okay. So the way to do that is open up a working directory, like what I'm doing here. Just open it up. And open up a command line window and make it larger if you are teaching and you are not. Like this. Is it better? Let's make it larger. Oh, I'm actually not directly programming the VI here, but just want to show you how to do it, make it larger. So basically, you just want to enter your home directory. Working directory actually. So CD and right click. Start getting here. If you put gvim and GCC into your path, environmental variable, you can directly compile it within the vim interface or the command line interface. So if you do vim and create a week2.c file, you'll directly open it up in the command line interface and allow you to add it in here. But I like the gvim interface slightly a little bit more, so I will just quit without saving, and I'll do gvim instead of vim. Gvim week2.c. Okay. So this one, so you can change your set GUI font. You can definitely use plugins to modify it, but I didn't. So I don't mind to just create a new window every time. Is that too small for the people sitting on the back? Can you see? Let me make it larger. How to change it like this. Okay. So now we can start programming our C programs for the homework. Practice the specifiers and for loops, while loops. So insert, press I, insert. Let's see what I want to introduce here. It's really good examples because I teach these C programs. It also teaches you the problems for homework 1 as well. It's due Thursday this week, I think. And because sometimes you don't know if it's signed or unsigned, how to deal with all the two's complement numbers. But I think by printing them out, you'll be able to see the differences. So it's a very good way to teach it, I think. So keep this window open so you can see the results. So first you have to include the header files, right? Standard IO file. If you have the GCC installed, this should be included in your computer. So directly just include it. Include the integer file. And this is not something you want to use for your embedded on both of them because you have the different header file for the pick. You don't have to worry about it because you follow the tutorial, it's going to directly load that header file for you. So no worries, I'm just telling you that you are not typing these 2 lines for your pick microcontroller embedded programming. And then you start your main. So now we are not returning anything. So it's not returning anything, just void. You're going to return a unsigned signed type, just change it accordingly. For example, I want to have a signed returning variable here. Then your main function has to follow that integer 8 bits definition. So we are not returning anything. So just void, okay? Just void. So now see, I have my cursor here. I can move the cursor to the bottom to the end of the line by pressing 0. By pressing the $sign. Okay, and I can press 0 to move it to the front of the line. Now sometimes the benefit of using Vim, because you just use your fingers on the keyboard, not the mouse. Okay, that can be very handy for a lot of cases. So if you want to insert, since right now I need the curly brackets, right? I'm going to insert curly brackets to the end of the line. I just press uppercase A, Shift A, so it's going to start insert. And then I do the curly brackets, Okay, and press enter, so change the line, and quit from escape from the keyboard. Okay, so now I need to insert my code into the curly brackets. So, but now I don't have room. I want to start a new line by pressing Shift and O. See? Shift and O will directly just start inserting and give you a indentation in front of it. And now, let's print something, okay? So I'm not returning anything, but let's print a integer x, which is a hex file, hex number. Okay, and I'm printing this guy. So int 8 underscore t. It's a signed number, right? It's a signed number because I don't have u in front of it. If I put a u here, that's unsigned. Now it comes to the good example here for you guys. It's gonna benefit your homework as well. So now I'm gonna plug in a specifier here. If I have a person sign and put a d here and have the variable x inserted into it. Okay? So d, person d, so d is decimal and it's signed. It's signed. However, I have my integer, I have my x defined as unsigned. What's gonna happen? What's gonna happen?
It's gonna do just the maximum value for FF or whatever it is. 255.
So signed is gonna treat it as a signed number. So what's actually in x? FF, what is FF? Negative 1. So FF is actually 8 ones, right? It's 8 ones. Our people sitting on the back know that it's from logic, right? F is 4 ones. FF is 8 ones. Any question about this? No? Okay.
Wouldn't it be 255 because it's unsigned with the
55?
or
255?
because you have the u int. It's an unsigned int right now, so wouldn't it be 255?
Yeah, unsigned is defined as unsigned, right? It's just going to store a unsigned number in there. But however, you are printing it out as a signed. I think it's going to be -1, but let's see. I might be wrong. I'm going to refund you something if I'm wrong since I wasted you like 10 minutes. So here, how to switch windows. It's just a simple trick here, right? Just Alt Tab, right? So you can switch windows. And what you want to do is GCC and V2, you can press the tab until you find the correct file. And -O is the output as exe file, okay? So compile it. It compiles. And then just simply type WE here and press tab until you see the correct exe file, right? And then run it. It's 255. Let's see. So
Just take the U off, that should be -1.
yeah, even though you want to print it as a signed, but still treating it as unsigned, right? So it's signed. Oh, I think it seems like whatever specifier you are using is not changing the type because the type is the type, right? It's just going to be unsigned. Now it's signed. I want to press colon and write. So I'm writing into the file. You save it. And now you press Alt Tab, switch windows, come here, and press the upper arrow so you can revoke that previous command you typed in here, GCC something, compile it, and then use this one, so you are getting -1 because it's signed.
So, what's the advantage of using Vim over like a IDE like VS Code?
I think no advantage. People usually it's lighter, probably smaller for the computer. A lot of people use VS Code. They convert the VS Code typing environment into the Vim commands window. So you learn how to use Vim. It's the same command. You can translate to VS Code. But a lot of people use mouse, still changing the lines and use mouse. But you can see people have a lot of experiences. They just convert into the Vim mode. So the same interface, just a different software. Same thing. I just don't have VS Code in here. You can use VS Code, but please convert it to the Vim mode. So you can use your Vim commands in there as well. Doesn't matter, it's just a different window. But still the same commands, right? Moving things around, still the same commands. Same thing. So if you want to use Vim, you have to install the GCC into your path. Make sense? Doesn't matter. You can definitely use VS Code. However, I recommend you guys convert it to the Vim mode so you can program like you are programming in Vim. All right? Do you get the point? Why do we want to use Vim commands?
So you don't touch your mouse.
You can also use it to program on a remote machine if you're like SSH.
Yeah, because in the future you become a digital design engineer in Apple, Qualcomm, Samsung, anywhere. You have to work with collaborative projects on the server, and all the servers are Linux, and all the scripts are written in VI, which is Vim. You open up the script, you have to program in Vim. You have to understand how to use the commands. You know, on the first day at the job, you're sitting in front of the desktop, people are looking at you, staring at your monitor, you are like, how do we move the line, move to the next line? How do we change a new line? How do we copy? You don't want to ask anybody, right? You want to be confident. You want to be able to produce on the first day. This is what the pros use in the industry, okay? You want to use what the pros use in the industry. Make sense? Doesn't matter, it's a VS Code, it's a Vim, it's GVim, VI, Linux, doesn't matter. It's going to be the same command lines, same band keys, okay? Just learn how to use it. It's good. Okay, switch back. You use VS Code, you don't have to switch back. I think it's all in the same environment. Okay, let's look at the second example. So how do you start a new line above this current line, the cursor's line? Insert a new line above it. How do you do it? Big O. How do we insert under below it? Lowercase o. Okay? So see, lowercase o, right? Escape. DD will delete that since I'm not using that. Move it up. And uppercase O. Okay? Got another one. So another variable. Do I want to use example? Let's use it. So unsigned, call it y, and still use the same number because that doesn't matter. Okay, here, I want to print it in a different format, okay? So I want to duplicate this line to the bottom or below it. How to do it? YY, just press YY. Didn't see anything, it's already duplicated. And press P, it's going to copy it below it. And so I want to, so it's unsigned, right? Unsigned. So I want to print it as a hex number. Okay. And it must be Y, right? Could you all see it? For the people sitting on the back, could you see the typing here? You could? Okay. Cool. All right. I'm trying to print out Y in a different format. Just want to try all these different specifiers and formats and binary numbers. So I'm printing this out as a hex number, which you're expecting. Unsigned hex number. Unsigned hex number, which you're expecting. Is it FF?
Yeah.
Colon, right, save, switch window, upper arrow, compile, run, FF. What's the problem?
Did you make a new line?
Yeah, I didn't start a new line. Okay, let's go back. You'll learn the new things from the practice, right? Now I know I should add a new line. A new line, cartridge, return to the front of the new line. Same thing for this guy. /n/r. Save. After the new line is probably not returning to the front of the line. So because the next time you want to print at the beginning of the line instead of somewhere else.
Yeah, but like, isn't it normally just go to the
Let's try it.
new line?
Can we try it?
Yeah.
Let's try it, yeah. question though, since I don't know as well. Let's see if that. Yeah. Sometimes the C compiler here with the laptop doesn't work the same way as the embedded C. So if it, for example, if you run it, it works here, doesn't mean it's going to work for the embedded little computer chip. Because we're running on this big, powerful Intel CPU, right? $200, $200 at least. Sometimes like $400 for the CPU itself. But the PIC microcontroller CPU is only $3. It's a huge difference. Huge difference. So simplifies things a lot, a lot. But can you run the operating system on the microcontroller? Usually. For the better ones you can. For the good ones you can. But for the Arduino ones, you probably don't have the memory to host that operating system. But for the ones, for example, I think the PIC one that we are using is able to host a operating system called real-time, FreeRTOS is a free real-time operating system. But for the Arduino's 8-bit microcontrollers, we cannot, unfortunately. You have used the Raspberry Pis, right? Raspberry Pis, they are hosting a Linux system on it. So you can, right? You can use microcontrollers to host a Linux system. And also for the ones in the car, you see a little GUI. The touchpad in the car, the modern cars, and they are usually hosting a Android operating system in there, and they could use usually the cars. These industry standard MCUs are from STM, ST semiconductors. So usually these are STM32. This kind of microcontrollers being used as the embedded system in the car. So they are definitely able to host a operating system in it. But still not expensive. These are like $20 for each at most. But these are like a few $100. Anyway, so let's see if I do colon write. Okay, switch windows, bring it up, compile, run. The same. Okay, thank you. So why do we still want to do it? Just in case this embedded system doesn't work that way, okay? All right. So let's create another one, YYP, okay? YYP, and let's change it to a character. I'm gonna rename it as Z, and 30. So this is something you want to know as a computer engineer, because it's ASCII table here. A character with a number of 0x30. You are looking at which column. So first, 0x30 is what kind of number type? Hex, right? So we want to look at the hex column. So find out 30, where's 30 here? So it's a character 0. So numbers, we can definitely just typing the number in the computer so the computer knows it's a number. However, for characters, how do you represent it? So there's a table called ASCII table, like this. Shows you the character's hex numbers. However, you have to print it out as a character in order to display that character. If you print it out as an integer, it's going to show the hex number, right? Does that make sense? Let's see it. Let's try it. So, before we switch back here, let's take a second look at it. For character 0, what's the hex number represents character 0? 0x30. What's the decimal number represents it? 48. Are they equal?
Yes.
Yes. It's the same number, but in a different format, right? Make sense?
Yeah.
Okay. So if I print out the variable as a character, I'm printing out what? 0. If I print out the character as a hex, I'm printing out 30. If I print it out as a decimal, I'm printing out 48. Okay, let's try it. Okay, character, data type, 00. So how do we replace the letter in Vim? Replace, just R. Insert is insert, it's bringing up the cursor. However, replace without disturbing or changing anything else, just press R. You see the cursor right now is blinking. It's taking the full letters height, right? If I press R, tell me the difference. Okay, it's giving you a little underscore. So showing you that you are ready to replace it with whatever you want. Just type it. I want to replace it with what? C. So I'm printing out a character, okay? So what's the name of the character? What's the name of the variable? So how do I want to do it? Replace it. R, Z, okay? And I want to save it, write. How do I write it into the file? Colon W. If I want to, just colon W, okay? It's written into it, saved, not Control S, okay? Saved. Colon W, not Control X, Control S. Switch windows, Alt, Tab. All right. Bring up the command, upper arrow. This one? No. This one? Yes. Compile it, enter. Execute it, enter. Is that correct?
No.
No?
No.
We printed it as a character.
Yeah?
Oh, I thought you meant all three of them.
Oh, yeah. I didn't comment them out, right? Are they correct? Yes. Okay, so if you don't want to see, that's a good question actually. If I don't want to see other things over here, they bother me. You want to comment them out, right? How do you comment that out? What's that? Oh, // yes. How to put / for two rows? So do V row. V will activate the selection mode. So do a Shift V will allow you to select the different rows and move the cursor down, and then colon norm, just norm, insert //. Okay, so it's gonna comment this out, and I want to do these two lines as well. Shift V. Okay, colon, norm, insert, //. Okay, if I undo it, U, redo it, Control R. Make sense? Okay, so now I only have the character, and I only have the print. I want to colon W, write it, and switch to the command line window, and bring up the GCC compiler, compile it, and then run it. So only show 0, because all the other ones are commented out. So now let's switch back. So how do I want to uncomment it? Still select it, Shift V. Okay, colon, norm, X, because X represents delete. So you are deleting one slash. So XX will be two slashes. Okay? Make sense? Okay.
Just deletes the first two characters.
Yes.
You do the next.
Yeah. So sometimes in Vim you want to duplicate. You want to say it.
Just a question, like when you go like Shift V, like do you select the lines and then automatically going down and like writing your characters? Does the like software do that for you, or is there a different command that you're doing after you select the lines?
I press the colon.
Colon, gotcha.
Yeah. Okay. Sometimes you want to select a large paragraph. So for example, I'm preparing for this lecture. I want to reuse the code for another one. So I do V, Shift V, and I can move the cursor down, but I don't want to do it sometimes. I just directly do a capitalize the G. We'll move the cursor to the bottom of the paragraph. Okay, and press Y. Okay, so it's gonna be copied. Press P. P will be paste. And now I want to undo it. Okay. So the cursor is here. I want to insert something. I want to include another header file. GG. Okay, GG will get you here, and uppercase O will start a new line above it, and then escape DD will delete it. Okay. Let's start a new variable. Another thing I want to print out. So for example, I don't want to print out this one as a character. I want to print out this one as a, even though this is a character data type, because you'll see this is a char. Oh, what I'm doing here is a character data type, right? But I can still print out this character as a number. So for example, I want to change it to what? Unsigned, for example, unsigned decimal. So what you're expecting?
48.
48. Let's do it. $48. Switch back. Okay. Signed. Because I didn't define it as unsigned or signed. So now I want to print it out as a signed. Very likely it will be 48, the 2's complement over 048. However, 048 is a positive number, doesn't have 1 in front of it. So it's going to be the same number, I think. Let's try it. 48, yes. So let's try a different number, okay? Try a bigger one. You guys let me know which one you want to try before we go call it today. Something like with the A in front of it, right? Do we have it? No.
It's only 7 bits.
Okay, that's all right. We don't have to do everything we have to do.
Tilde maybe?
Hmm?
Maybe try the tilde. Because I think aren't characters only 7 bits, or are they still 8 bits?
Yeah. 7 bits as a maximum. Okay, let's try a different number here. 3 more minutes. So what do I want to do here? Oh, the increments. What's the command to start a new line below it?
Big O.
Lowercase o. Lowercase o. That's okay. You haven't done that yet.
Is there like a Vim command sheet you could just look it up?
Yeah, just search it online. There's so many. I have one tutorial on my website as well. So unsigned, let's call it variable. This one equals 0xab, for example. 0xab. It's just a one variable. So I have 3 minutes. Okay. And YYP, right? I want to print this guy as unsigned, for example, and I want to call it, just delete it and insert var0. This is what I want to do. Yes. Okay. Anyway, so this guy, this is AB. So var0 is AB, right? It's unsigned AB. And if I print it out as v0, what's gonna happen? It's just gonna print out that, right? Let's see. See, 171 because U is unsigned decimal, right? Let's switch it to hex. It's gonna be AB, right?
Yeah.
Okay, AB. What I'm trying to do is, so what if I have, I think I pressed. Okay, cool. So if I do very last example, okay? This. If I do this, am I printing out AB or AC? AB, because it's going to print it out first. It's going to run the operation first and then plus 1 to it, right? So now let's try a different one. Give me one more minute. We'll run it really quick, see if we can do it. So you are expecting what? A, B, A, C, right? Okay, let's try it. Oh, A, D?
What?
Oh, because I already added. Okay, we'll see you Wednesday.